Welcome to Mr. Brandt's 5th grade everyday math review. In this video, we're going over lesson 6.4, which is working with data in line plots. And the numbers up here are going to represent pop that 9 grandkids have wasted. And this group of grandkids, grandfathers, do not really like it when they waste pop. So we've got a line for our line plot down here. We need to start with a title. So our title is going to be Pop Wasted by Grandkids. And the numbers that we're going to be plotting are based on the ounces that they've wasted. So we need to find our biggest number and our smallest number. So our biggest number, our smallest number is 1. Our biggest number is 5.5. With a line plot, we do not need to start at 0. Because it's a line, we know that it continues in both directions. So I'm going to make my first mark here 1. And then I'm going to go out to 5. So 1, 2, 3, 4, 5. Oops, I made a mistake. I actually need to go out to 6. I need to go above the highest number. So I need to go out to 6. Now, since it's fractions and all my fractions are half, I can divide the rest of these into halves. And for this particular one, I'm going to choose not to label those. So let's go ahead and add our data to the line plot. So we've got one grandchild wasted 2 ounces. If you watched the last video, I either put a slash or a dot next to it to know that I've already plotted that data. So the next grandkid wasted 3.5 ounces. Then 2.5 ounces, 4 ounces, 5.5 ounces, 1 ounce, 2.5 ounces, 3.5 ounces, and another one for 2.5 ounces. Now this particular grandpa, he likes to deal with numbers, and so he was curious how much total pop the kids had wasted. And so to do that, he's going to add up the data. And for this, I'm going to go ahead and do the ones with halves first. So this will be 2.5, 2.5, 2.5. So if I added all that together, 2.5, 2.5, and 2.5, that's going to equal 7.5. And then the other mark over here, I'm going to switch colors. So we had 3.5 and 3.5. And I know that 3.5 plus 3.5 is 7. So now I'm going to go through and do the columns that I haven't already done. And just to make sure I don't make a mistake, I've already done this one and I've done this one. So I'm going to add up the whole numbers. 1 plus 2 is 3. 3 plus 4 is 7. So my whole numbers are 7, and this isn't the best organized. So I've got 7.5. I have 7. I just had another 7 for my whole numbers, and then the last one that I haven't done 5.5. So I'm going to go ahead and add that together. 1/2 and 1/2 is 2 halves. 7 plus 7 is 14, plus 7 is 21, plus 5 is 26. So 26 and 2 halves is equal to 27. So these grandkids wasted 27 total ounces of pop. Now, the next thing he wanted to do was figure out on average, so on average, if we're going to even out the data, on average, how much did each kid waste? So to figure that out, we take the total amount, so there's 27, and we divide by how many numbers there are. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 data points. So to find the average of the total wasted by each child, it'd be 27 divided by 9, and that equals 3. So the average amount is 3 ounces. We could label it OZ per child. For the practice for lesson 6.5, we're going to be doing some multiplying and dividing by powers of 10. So the first problem, we have 3.4 times 10 to the third. And if you would go back and watch the video, we talked about a couple of different ways to do it. One of them is kind of start with an estimate. Another way is just to move the decimal. I'm going to do both for both problems. For our estimate, maybe I shouldn't say estimate, but I start by finding an estimate. So I'm going to look at the greatest place, so that's the 3. The 3 is worth 3. The 3 is worth 3, and then we're going to multiply that by 10 to the third. Well, I know that 10 to the third equals 10 times 10 times 10, which is 1,000. So 3 times 1,000 is 3,000. 3,000 has 4 digits. So the 3 and the 4 need to stay next to each other. So if I had 4 digits, we'd have 3, 4, and then our 2 zeros and a decimal at the end. So 3 and 4/10 times 10 to the third equals 3,400. Another way I can think about doing that is by moving that decimal point. And remember, each time, or when we multiply, the decimal point moves to the right, and each power of 10, it moves to the right 1 spot. So times 10 times 10 and times 10. There are 2 spots that need to be filled in with zeros. Our decimal will be at the end, and we get 3,400. So again, it doesn't matter which method we use, you're still going to end up with the same amount. Okay, for our last problem, we're going to do 198 and 7/10. And we're going to divide this by 10 to the second power. I'm going to flip it around this time, and I'm going to start by moving the decimal first. So dividing by 10 to the second power, when we divide, the decimal moves to the left. So this will be divided by 10, and then another divided by 10. So 10 tens is 100. When we divide it by 100, we move it, the decimal to the left 2 spots. So our decimal goes right there, which gives us an answer of 1 and 987 hundredths. Excuse me, 1 and 987 thousandths. If we're going to use the other way of thinking about this, so 198 and 7/10 divided by 10 to the second. I'm going to round this time. So I'm going to make the 198 and 7/10 would round to 200. So 200 divided by 100, because 10 to the second is 100. 200 divided by 100 equals 1. or excuse me, that equals 2. So what's the closest I can get to 2 with the digits 1987? Where would I put the decimal to get a number close to 2? Well, I'd have to put it here for 1 and 987 thousandths. So again, doesn't matter which method we use, we're still going to end up with the same answer.